Hello everyone and welcome to today's webinar on live demo of static and dynamic resistance measurement on HV circuit breakers. My name is Sanjay Yadav and will be hosting this session today. Speaker for today's session is Mr. Ali Hussain, who is an application engineer at Megger Middle East. Before handing the mic to Mr. Ali, I would like to highlight a few points. You all are being muted to avoid any disturbance during the presentation. Do park any question you may have for the Q&A session at the end of the webinar or share it in the chat window. All questions will be answered at the end of the session by Mr. Ali. We also have a Megger exclusive page on Facebook and LinkedIn. I will share the link in the chat window so that you can go through that link after the webinar and you can just follow us for regular updates. There are a lot of webinars, upcoming webinars in October. I will share the link in the chat section. So you can go through that link after the webinar and register yourself. These webinars are free of cost and very informative. I now hand over the control to Mr. Ali. So let's get started.
Thank you, Sanjay. Thank you very much. Welcome everybody to this webinar about static and dynamic resistance measurement. Today's session will be slightly light on the theoretical part. We are going to conduct, however, a live demo. I have the whole setup and the camera is ready and everything is connected. We'll do some real measurement and check some results so you can understand better what the theoretical part is talking about. Again, if you have any question, please leave that question for me during the webinar and I will answer all these questions at the end. Thank you very much and let's start. So first I'm going to give you some introduction about our contact types in HV circuit breaker. Since we are doing resistance measurement, the contacts is the most important thing about that. Then we are going to talk about static resistance. What does it mean and how do we accomplish that test? After that, dynamic resistance. Then we will go through some of Megger solution. At the end, I will open my live camera and do an actual measurement for you on a circuit breaker that we have here. So starting with the introduction. First, what is a circuit breaker? It seems a very simple answer for that. It's a switch that we operate in faulty condition or even in normal condition to break the circuit and protect our asset from, for example, overload or short circuit currents. But what is important about that? What do I need in this circuit breaker to be a perfect conductor? Means has minimum losses, no heat generated when it's in the closed position, to be a perfect insulator when it's in the open position. And while in between, in the open and the close, during these two operations, I needed to break as safely as possible, not only in normal condition, but also as well in faulty or huge current like short circuit currents condition as well. That's why a proper maintenance and the proper checking of my contact system, which the part that carrying the current is very vital and crucial test to be done. So in order to make it more focused on high voltage circuit breaker, I will divide, let's say, circuit breaker into two categories. Low voltage circuit breaker, which usually below 1000 volt. Usually these circuit breakers are having their own tripping mechanism implemented inside them, either through electronic circuit or thermal or magnetic mechanisms. And usually the testing for them, whether it's timing, is usually done through a primary injection, where you bring a huge device and inject huge amount of currents to trip these kinds of circuit breakers. while in medium and high voltage situation, which usually greater than 1 kilovolt, usually these circuit breakers does not have the protection implemented directly inside them. Usually they will receive a contact from a protection relay outside them, thus having no actual operation in them, thus they are remotely controlled. Usually these will be tested using circuit breaker analyzer devices. Our session today will be mainly focused on HV circuit breaker. Some of the concepts here also apply for medium voltage circuit breaker or circuit breaker used in distribution system. So I will divide them into two categories: live tank and dead tank for the HV circuit breakers. For the live tank, meaning that the container of the circuit breaker is considered dangerous and usually is putting in high top area, is porcelain to insulate it. There are different insulating media, for example, vacuum for high voltage circuit breaker, or in older days they were using oil. There are bulk oil and minimum oil. Also, there was a technology of air blast. It's a very reliable technology to blast air on the contacts while the breaker is opening or closing to cool it down and to extinguish the arcing. And nowadays, which is most famous or most majorly used, SF6, hexafluoride gas. It's a very good insulator. It can minimize the circuit breaker size very drastically compared to the other insulating media, and it works very well in high voltage environments. The other types called dead tank. Dead tanks meaning your body of the circuit breaker enclosure is grounded. So some of the same technologies also applied in these dead tanks circuit breakers. But the thing I want to mention or focus more on this is the GIS systems, or what we call gas insulated switchgear, meaning your all equipment from this connector, earth switches, CT, VT, as long as also as the circuit breaker, all included in gas, not only the circuit breaker. That usually gas is SF6 gas. And as I mentioned earlier, most of the circuit breakers nowadays are using the SF6 as insulation media. And in SF6, and since this is a resistance focused webinar, we'll talk about the contact system. So let's go through some of the features or components in SF6 gas circuit breakers. So there is a lot of components as shown in the picture here. I'm not going to go through all of them, but the main component that we are going to talk about is the contact system. Two conductor touching and carrying the current. In an SF6 circuit breaker, the contact system mainly have two parts. Have a moving contact, I'm sorry, it have a main contact and an arcing contact. And this contact system, having these two, are for a very good reason. Some few breakers, minimum breakers, do not have an arcing contact, but the majority of them, the SF6 breakers, do have an arcing contact. The main contact job is to carry the high current during normal condition in a very minimum losses, and the arcing contact job is to during breaking of the circuit breaker or closing first and opening last, to quench or take the energy generated from the arcing in the opening and the closing operation. That's why it's called arcing contacts. Now, if I need to make sure that the operation of these two contacts are in a healthy condition and they have no problem in them, I need to check both these contacts, the main contact and an arcing contact. Just to give you a brief way or brief picture about the stages that these two contacts go in an open operation. For example, first we start that the two contacts are closed. You can see both contacts are touching. I have my main contacts on the sides here and my arcing contacts in the middle are touching. Once I give an open command to the circuit breaker and the mechanism start moving after a short time, my arcing contact will start to separate. And once my arcing contact separate, it will separate first. My main contact separate first. My arcing contact is still in touch with the other end. Then my arcing contact start to separate, thus creating an arc. And this arc will be extinguished by the SF6 gas. Usually there will be pressure here happening, extinguishing the arc and cooling the two contacts, the one moving and the one fixed. And then the breaker will be in the open position. So this is basically a picture by picture preview of an opening operation of an SF6 gas circuit breaker, with showing the main and arcing contact position during this operation. It is very important to keep this in mind, since a significant portion of our webinar today will be based on this operation. I will bring it back later on, but it's very nice for you to understand what's going on inside the contact during operation. Now, starting with our first topic, static resistance. It's the name we call static resistance, but it has maybe different names. You might are familiar with it. It's a very common test. Some people call it micro ohm test for the circuit breaker. Some people call it contact resistance of the circuit breaker. They all mean the same thing. And to verify that the contact resistance is very low, usually in the micro ohm range. In order to measure a resistance in the micro ohm, you need to inject high current, high DC current. And by standard IEEE and IEC, the minimum current that you can inject is actually 50 amps per IEC, or even 100 amps by IEEE. Some people even recommend that you inject 10% of your rated current for the circuit breaker, the AC rated current. Now, this method, in order to get the maximum accuracy and to not get any errors because of the wirings or the cabling of the test equipment, it will be using the 4-wire measurement, meaning 2 wires injecting current, another 2 wires measuring the voltage, thus giving you the resistance. The voltage divided by the current will give you the resistance value. And this operation, of course, is done in the fully closed position. This is a diagram just showing you how the connection is done. You can see here the 2 big cablings or wires is used for injecting the current, and the 2 small ones are used to measure this resistance. Some typical static resistance measurement values, for example, for generator circuit breakers, since they usually under normal load have very high current, usually because you have a medium voltage with maybe huge power, so you'll usually have an ohm meter or ohm value in the range of from 1 to 10 micro ohm. In transmission or line circuit breakers, you usually will have from 20 to 200, depending on the rating and the voltage level and so on. And distribution, that can go up to 1000 micro ohm. Now, static resistance measurement, if I want to do it, usually it will be focused on the main contacts. But what about my arcing contact? It's still part of my contact system. So how can I do it using the static resistance measurement? Now, the way they build these arcing contacts, they usually are from a very tough material that have a slightly higher resistance value from the main contact. Take a close picture of it. You can see that both, when you are doing a static resistance measurement, both the main and the arcing contact are in parallel together. So I basically are measuring both at the same time. But as I mentioned earlier, usually the arcing contact will be having a much higher resistance value. And if you have a high resistance in parallel with a low resistance, basically the equivalent resistance of both will be something very close to the lower resistance. So if you do the math, for an example, you have a 30 micro ohm main contact and 1000 micro ohm, which is 1 milli arcing contact, and you took the parallel out of them, you will get a value equal to 29.12 micro ohm, which is almost like 30 micro ohm. It's like a negligible resistance value. I cannot really measure it very Hello? Seems that my audio was lost for a very few seconds. Can you verify that you can hear me, Sanjay?
Yes, yes, we can hear you, Ali.
Okay. Apologize for this problem. Okay, let's continue. Dynamic resistance measurement is done while the breaker is in the opening position. If you remember from the slide shown earlier of a preview of the breaker in open operation, if I took the portion that where the only arcing contacts are touching together during operation, and I did a resistance measurement on that part or in that specific period, I can get the resistance of my arcing contact because my main contact has separated from each other. As the picture shown here, I have my only two arcing contact in touching with each other. Thus, the true measurement of my arcing contacts can be done in this operation. So let's go ahead and say during my opening, I did a resistance measurement with a very precise and specific tester. What the result will look like for me? To look like something like this. You will have, you started first with an closed position where both your contacts are enclosed. Then I did get a small jump, some kind of unstable jump. It's not something I can get anything out of. It's going from up 200, up to 150, up to 100, going up and down. So it's not really something stable. And then I got the open position, which then resistance will become infinity, like an insulating resistance now. So can I really utilize this information to tell me the condition of my arcing contact? Is it having a low is going high. It's really difficult. It's very difficult to get a number that I can utilize. Like in the SRM or the static resistance measurement, I can get a number because nothing is moving, no movement, no going up and down or bouncing or anything. So how can I make this measurement better? How can I have a useful information from this measurement? In order to do that, you need first to go through, or in addition to this test, do what we call a travel motion test. Now, as you understand, a circuit breaker is a mechanical device. You have some parts moving, spring and arms and so on. Now, some of these parts might have a rotary movement, others will have a linear movement. I need to capture this motion and compare this motion with my dynamic resistance measurement, and I will explain to you why later on. But first, how do I capture this motion? We'll use something called transducer or motion transducer, where it will change the measurement from a movement measurement, a distance in millimeter, to an electrical signal to my tester or circuit breaker analyzer, and will give me the value of the motion during the operation. Now, if I added DRM or the dynamic resistance measurement and the travel motion on the same curve or graph, I will get something like this. This is my resistance value as before, and this is my motion. Now I have this motion in millimeter, and I know that this middle part where I have this going up and down is the period where my arcing contact is touching. So this part, if I compare it with my motion part, I can get for how long in millimeter my two arcing contact are touching each other. So if I did this test now and I got a value of, let's say, 5 or 3 millimeter of touching each other, or depend on the circuit breaker design really, and then I did this test after 1 or 2 years, for example, and I get slightly shorter length value. This means that my arcing contact has started to wear out, and really I can detect that without the need of opening any circuit breaker. So this is some picture of this is my main contact and this is my arcing contact. I'm sorry, this is my fixed contact and this is my moving contact. Both of them are arcing contacts, and you can see this is an old one wearing out and this is a new one compared to it. And if you put them together and take a slightly measurement of them, you will see some difference in these two contacts. And the same thing here as well. And this difference can be measured without the requirement of opening your circuit breaker, especially if it's, for example, in a GIS system where opening this is quite the extensive work. You can do it using this test, which does not really require you to open your circuit breaker at all. So this is how you can check the main contact using the SRM and the arcing contact using the DRM test. So we'll go through some of Megger solution that can help you do both these tests. Megger has been very well known in producing circuit breaker analyzers since more than 30 years, and This is some of our famous circuit breaker analyzer names. For example, the Eagle. This might be very famous one. And also we have the TM 1800 and 1700. These circuit breaker analyzer, you can add to them an accessory called SDRM, or stands for static and dynamic resistance measurement. And you can do both tests, the static and the dynamic resistance, with this a small box. It's used a capacitor based technique to make it very, very small, and can give you current up to 250 ampere for a short period of time, which what you really need actually to do these tests. Or if you want to do only, for example, SRM or contact resistance, we have a huge range of digital low resistance ohm meter or micro ohm meters with different advantages to each other. In summary, before we go to our live demo, SRM is a regular test, important test that it's always done to check that the main contacts are in a very good condition. It's very easy to do this test. While DRM, it's kind of require you a lot, maybe addition with doing motion test, but it really can give you a good picture about the condition of your arcing contact. And remember, it's always better to use high current so you can get maximum resolution, and always perform travel measurement or motion test simultaneously with DRM to get the best result. Otherwise, DRM alone will not really give you a very useful information by itself, as we shown in a previous slide. So now we will go to our live demo. I have my camera here set up on my live demo. If you have any question, please leave that in the question segment, and I will definitely answer that for you after the end of this live demo. Our live demo, I have three devices connected here with me. The first device in the middle is our TM1800. It's a circuit breaker analyzer designed to test circuit breaker in HV high voltage circuit breaker in a very great detail. The second equipment I have here is an air circuit breaker. This is not your typical SF6 gas circuit breaker. Unfortunately, I don't have one with me here in the office, but this will do to showcase for you the SRM and DRM measurement. But unfortunately, this circuit breaker, it's an LV circuit breaker, did not have any access to mount any motion transducer to it. So in order to get the motion measurement in conjunction with the resistance measurement in the DRM test, I have added our circuit breaker simulator, which is basically a device that can give me simulated times and travel measurement from this device. So combining both these together, I can get a DRM and a motion travel test for your convenient and can say a live or test environment, just for you to understand that better. So let's start and begin with the SRM test. I have my SDRM accessories connected on the back of the circuit breaker. I have three SDRM bare phase. They all connected, and the current and voltage cables are connected to the breaker and 4-wire measurement mode. And I will be injecting their full current up to 200 or 250 amps. And let's see what is the measurement for that. I have already set the test plan and configuration, so we don't waste time on that. So I will go to my TM here. And I'm selecting my three-phase SRM, static resistance measurement. As you can see here, I will just operate the SRM modules and see what the measurement will look like for. Check. Now the capacitor has released the charge into the breaker, and I got some measurement value. So let me zoom in more for you so you can see the result that we got. Hope the picture is clear for your convenience. Here, this is the resistance value with time. This doesn't really matter for me because nothing will change, but what is important for me is the actual parameters. The resistance for phase A, B, and C is shown here, having a range between 33 to 31 micro ohm. This is the unit here, micro ohm. Shown for me, this is the resistance value, and if you want to see the injected and measured voltage, it's shown here as well as reference value for you. Now the SRM module can give up to 250, but because of the resistance value, it only went to 150 ampere in each phase, which is not bad since, as I mentioned earlier, the IEC standard specify a minimum of 50 ampere or IEEE 100 ampere. If I had a generator circuit breaker, which has a very minimum, very low ohm resistance measurement, I might got up to 250 ampere for the measurement. So this is basically SRM. I have my breaker closed and I did the test on that breaker while it's closed, and this is the measurement that I have got. Now let's go to the DRI measurement and try to do the measurement for them and see how the results will look like. So this is this. Now the breaker is in the closed position. I will do an open DRM and see the result. So there you go. So let's start and do a measurement in the open DRM. Okay. Now my breaker has opened. See that the breaker board. You can see it's in the off position, open, and the resistance measurement value has been shown to me here. So as I mentioned earlier to you, the dynamic resistance measurement is not something you can get a parameter out of, a number, a meaningful number out of. That's why we don't see any resistance parameter shown to you here. It's only showing you parameters for the motion, what you call stroke or travel rebound, and they all in millimeter. But what is important for us is not the parameters here, it's the graph itself. That's why it is important for me to measure these two values. As I mentioned earlier for you, this is air circuit breaker, not SF6, which has two contact systems. Same as I showed you on the slide. Unfortunately, I don't have something like that in the office where we have to showcase you, but still, it can give me a similar result. And you can see a slight jump here then before going to the open position, and from that I can measure my can say contact or arcing contact length in comparison with the motion test. In order to do that, I take my cursors here. At the time where my connection, or to the time where my resistance has changed. Can really play on with the zoom to get a better idea about that, or you can cancel it to not show the other phases and do each phase by itself to get the resistance. So I'm going to just remove the other two phases and only work with the red phase. We'll take this to the point of the jump. In SF6 circuit breaker, you will definitely see the jump, but in this type, it will not be as good as you can see. And then I'll take it to the once we get infinity again here. This is one of the circuit breaker for you. And the motion between cursor 1 and cursor 2 is measured, and the difference is directly shown for you here. 1 millimeter is the measured value of your arcing contact. Of course, I need to maybe adjust a little bit, but this is because of the air circuit breaker that we have here. And the motion is not proportional because I'm taking it from a different device. As I did for this phase, I can do for the other phases as well. I'll just step this value or write it down. So I'll remove this phase and put the other phase. And do the same thing again, just to get and see the arcing contact of each phase as well. I do this for red, yellow, and blue as well as green. So this is basically DRM. We can do it in opening the breaker or in closing the breaker as well. Let's do it in the closing the breaker since it's open now, and see what difference will be shown for us here. Will be basically the opposite. So of going to infinity, it will come to contact resistance. And what we think is the part from here. So go right ahead and start on. Might give you maybe an error signal. So that, but okay. So now my measurement, you can see it, a slight jump was coming out of infinity to the stable measurement. Now, the jump is slightly zoomed in, so I need to, I'm sorry, zoomed out, so I need to zoom in. So I've already got layout. Okay. This exit. I want to get even better. And let's remove other faces. This. You can see it's a little bit difficult. It's more difficult in the closing to get the two jump. This breaker, but in SF6 circuit breaker, it will be as shown in the presentation picture. Here, and then having 2 millimeter difference, for example, should be very similar to the opening, but as I mentioned earlier, I'm taking my motion measurement from my circuit breaker simulator. That's why the values are not consistent with each other, but in a real environment, it will be so. This is just an example to show you how the DRM and the SRM work. Thank you very much for joining us this live demo and this webinar. Now I'll be shifting to the question session, and I will be answering any question that you have, providing you with satisfactory answer. So let's go and do that. So, Sanjay, will you please give me the questions if possible?
So,
okay.
so there is a question from Mohammed.
Yes.
When we should do this test period?
You're talking about the SRM or the RM? Oh, anyway, I will answer you for both. The SRM test, it is a periodic test that you need to do with any maintenance, a full maintenance of your circuit breaker. And the test is not really that difficult or that expensive for you to do, but for DRM test, it is not something you will regularly require to do. It is something that usually done after huge short circuit currents in order to check that the arcing contact has no issues to it. So it's not a regular test that we'll usually do in any period maintenance. But the thing that I want to mention to you is that, for example, when you are ordering a circuit breaker or you have a new circuit breaker, it's better to have a reference curve or a reference DRM test done at the factory before you receive that circuit breaker. So later on, when you want to compare, when you do the test after a short circuit, you have a reference that you can compare with. Okay, next question.
There are a lot of questions coming in, but can you choose which one you need to answer? Because if I
Okay, I'll go through them all. I will go through them myself. The next question says how dynamic resistance measurement is applicable for LV air circuit breaker. That's a very good question, since our example on this circuit breaker and LV ACB, it's not applicable, and you can see from the curves that I get, it's not as I showed you in the picture. I am only using this as an example to show you what to expect from the curve and some of the functionality of the devices and a connection, but it's not applicable for ACBs in low voltage. It's actually very expensive test to do it for these type of circuit breaker. It is applicable mainly for SF6 gas type circuit breaker, since they do have this contact system type, having an arcing and a main contact. Another question I'm getting here, it is what is the acceptable criteria for travel test? Now, travel test is relative to the technical specification or the test done from the manufacturer. So it's really basically depending on your circuit breaker. If you have the travel motion test result done at the factory, you can compare with them and see what changed. For example, are you moving more than you should be, what we call stroke, or are you moving faster speed, or you having bounces, a lot of bounces at the end or at the beginning of the operation, meaning you have something maybe loose, it's not being stopped or initiated correctly. The next question is saying that the unit can initiate more than 100 amps. The TM itself does not inject current. The TM only accepts measurement values. What I am using is actually an SDRM module, as is shown in the picture here. It's not shown in the video, unfortunately. They are on the back of the circuit breaker. I'm using this module. It is on the back of the circuit breaker. I have 3 of them connected to each phase. That module or accessory, basically it's a super capacitor. A super capacitor is basically, you can say, you will charge it to 2 or 5 volts, for example, and then you will release this charge on a short circuit, thus giving you very high current. You can watch some YouTube videos or something like that. Just try super capacitors and you will see that they can produce very high current from them. We are using that technology in a controlled manner to give and measuring that current throughout this measurement. That's why you see the curve of the current, to give you the best resistance measurement value. Another question I'm having here is that is it necessary to connect motion transducer to the circuit breaker when conducting DRM test? Yes, it is very, very necessary to do that. And as I mentioned earlier, from this slide, we go back to this slide, doing this test only, you are not benefiting anything. You already know the SRM or the normal contact resistance measurement. But what is the benefit that you get from the DRM? Not really that much. Yes, you can maybe find the trip time when the circuit breaker tripped. Maybe that's a benefit you can get, but the actual condition of your arcing contacts, it's not really beneficial too much for you using only DRM to do that. That's why you need the travel motion test in order to measure that motion with respect to this jump in resistance. We have, I believe, some time to answer more questions. Another question is, what is the acceptable value for DRM and how to perform DRM for medium voltage GIS breakers? As I mentioned earlier, for the DRM, we are considering the value of the motion or the difference between the motion to get the length of the arcing contact. So depending on your arcing contact system, when it starts to wear out, especially after huge fault current, you will go to a certain limit, usually specified by your manufacturer. Once you go to that limit, it will not be applicable or even safe for you to operate your circuit breaker, especially in faulty conditions. And for the second part of the question, how to perform DRM for medium voltage GIS system, Unfortunately, for the medium voltage GIS system, I'm slightly familiar with these. They don't really give you access to their main contact, not even through earthing linkings. Usually the earthing linking even buried deep inside, you cannot access to them. Unfortunately, so this is not really going to be easy to be performed on these types of circuit breaker without opening the whole circuit breaker or the GIS system, which in case you already did opening, you don't really need to do the test anymore because you just can measure the length directly from the circuit breaker. Another question is, how can we analyze CB is good or not by SDRM? As I mentioned earlier, again and again, I believe I have answered this question. Once you get this length of the arcing contact, you will compare it with the one came from your technical specification of the device or with a previous measurement done for the DRM. That's why it is very important to ask the manufacturer of these circuit breakers to provide this information for you in order to be able to compare it with present result. Otherwise, it's not really something you just set a limit to it without knowing what was the previous measurement was. Okay. Someone saying that his audio was very poor at the end and he wants to understand how we can make the make and the break points for the DRM with the motion test. So let me go back to the camera and show that for you. What I'm going to show you here, it is, you can see the worst case scenario, but for an actual SF6 GIS system, or even not GIS system, the measurement will be much better than this. So in my circuit breaker analyzer here, my analyzer view, I can set cursors at certain point of time. Usually I will set these cursors at the start and the end of this jump resistance for the arcing contact. Now for this AIS or air circuit breaker, that's very difficult to define these two jumps. But for GIS or SF6 systems, it will be very easy to do that just fine. They can do them really easier. If you are already owning the DRM or SDRM and you want a full training on to do that, please contact me and I will be happy to give you in great detail how to achieve that, how to connect, and how to perform a test for your SF6 breaker. Apparently, we're having so much question. I am very sorry for that. We are out of time. For the rest of the question, I will definitely answer you via email later on. Thank you very much, everyone, for joining us in this webinar today. I hope you learned new things today. I hope also you had fun with this live demo. If you have any question or additional question, if you want more information, if you want a demo, if you want even a training, you have the device and you want a training, please contact me on my email address, ali.hossein@megar.com. I will be more than happy to provide all of that to you. As for this recording of this webinar, the recording will be sent to you after 24 hours from the ending of this webinar automatically by GoToWebinar. Also, some of you asked me to share the presentation. I will try to attach the PDF copy of this presentation to that follow-up email that you receive one day later from now. Thank you very much for joining us, and see you in our next webinars. Have a good day, stay safe, and goodbye.